Hello everyone. Today we're going to present you our new study, which is titled as Exploratory Data Analysis and Modeling of Twitter Mental Health Disorders and Music Preferences for Machine Learning Applications. I'm Borader and my friend is Alperen Demirci. So let's begin. Our problem, let's talk about our question first. If you know users' tweets and their music preferences, can we predict which mental disorder they belong to or they self-diagnose themselves? Talking about our motivations, mental health disorders are critical global health challenges. There is no denying that mental health disorders are a part of our society and increasing risk of our society with the never-ending development of technology. Another one can be social media and music can provide unique opportunities to analyze mental health-related patterns. So this is actually our initial hypothesis that we are trying to prove. Another motivation is providing an early detection and recognition of mental disorders based on user activity, which is here music preference and tweets. So if we can go back, Alperen. So our thinking, our opinion was, okay, we know that social media is widely used in this era, and it probably will be used widely. So Twitter, or with its new name X, is one of the most popular among them. And we thought like if we had a good performing model that we can use with real-time data, which are tweets, we can, analyze them and infer if a user has a mental health disorder. And with this data, with this inferring, we can take action before something bad happens to the users. We can move on. So let's talk about our objectives. Analyzing multimodal data, which are tweets and song lyrics, to classify mental health disorders. We have two different but not separate data sets here, which are, as I listed before, tweets and song lyrics. So we're going to be using two different data sets in a hybrid data set. Using advanced feature extraction techniques, which are mental BERT and lyrics BERT as our best performing ones. Applying machine learning classifiers to improve classification accuracy. As I said, we are using those big models for feature extraction, and we are using some different, let me say, more lightweight classifiers, algorithms, to get a faster classification result, and to address the usability of the dataset using results obtained from modeling. We can move on. So to understand our data, first dataset is mental health tweet datasets. It consists 32 million tweets. It's a really big textual data. It has disorders as labels, depression, anxiety, PTSD, borderline, bipolar, and panic disorders. And for our music lyrics datasets, it has 400,000 song lyrics with its metadata, which can be listed as artist, title, genre. Talking about our challenges, there's a huge class imbalance. The depression label is incredibly overrepresented, so it's a problem that we need to solve. Multilingual data and noisy inputs and modeling of natural language. These are common problems in the natural language processing practice. Data is indeed multilingual, and we are using English versions of those models. So we had to deal with the multilinguality problem. And as a nature of the natural language, there are some noisy inputs, so we had to solve them too. We can move on. So talking about data preparation, for our tweets datasets, we remove non-English tweets, duplicates, and irrelevant content to, increase the quality of our data. As I said before, non-English tweets do not contribute anything for our models. Balanced datasets with 10,000 tweets per disorder to solve the overrepresentation problem of the depression class and to get a good sample of the data itself. Converted emojis to texts, hashtag and URL removal, and correction of spelling. Talking about this, emojis, they do not contribute to data by themselves, but, some tweets have textual data and emojis with them. So converting the emojis to their represented names, it can, and it does contribute our data. Hashtag and URL removal, some data inputs are just some links or some hashtags, some retweets. They do not contribute anything to our data, so we have to remove them. And, spell correction, stemming, lemmatizing, these are some common practices in natural language processing. Talking about music datasets, we removed excessively long lyrics. We used 5,000 characters as a filter. We removed more than 5,000 characters lyrics. This also helped us to correct some of the wrong API results. We imputed missing lyrics and normalized artist and song titles. So naturally, we had more than one instances of most of the songs. But interestingly, some songs did not have any lyric data. So we use the already existing lyrics for those songs and retrieve the missing lyrics using those songs. Filter non-Latin characters, corrected spelling of words. Again, filtering non-Latin characters, it helped us with our linguality problem limitation here. And also the spell correction is a, as I said, common natural language processing method. So that's for me for this presentation. The next part will be presented by my friend Alperen.
So thanks, Bora. I'm going to be continuing with the modeling part and the evaluation part of our machine learning models. So we have used different kind of BERT models for feature extraction, and the best of them were mental BERT for the tweeted data, lyrics BERT for the musical data. We have used the based BERT model as a baseline for comparison, but we couldn't see much difference. So we only put these two best models for our data sets. And on top of our extracted features, we have tried three different classification models, such as the naive Bayes model as a baseline, and an MLP model, multi-layer perceptron model, and then XGBoost, which is a ensemble tree model, and also the XGBoost has performed the best in our experiment. So let's look at our results. So after the evaluation, you can see if we use only the tweets on the mental disorder classification by the best combination in our experiments, mental BERT plus the XGBoost on top of the features, we have achieved an F1 score as 20%, and then ROC AUC score as 54%, which is not satisfactory. By using the song lyrics for the mental health disorder classification, by the best combination of the using GREEXPERT for feature extraction and then XGBoost to classify these features based on the features, we have achieved a slightly better F1 score compared to the tweets classification as 24%, and then ROC AUC score as the mean of our 6 classes, 57%. So by only looking at these metrics, we may say that for the same data sets, lyrics may provide the richer context from the classification manner. So what was our limitations? Because to be honest, we couldn't get a satisfactory result for deployment. And for the tweets dataset, we can say the dataset consisted of mostly mislabeled data points, and the text features had informal language such as slang or aberrations. And our models as MentalBERT and LyricsBERT supported only English. So the multilinguality, which was a problem that we couldn't resolve in an effective manner because we have 32 million data points in the tweets dataset and 400K data points in the lyrics dataset. And the language detection models were performing really poorly from the time manner. So that's why we only checked the language compliance just by checking the UTF-8 representation of the messages. We dropped the messages which contain non-English, non-Latin characters, actually. So for the lyrics dataset, we had overrepresentation of certain artists such as BTS. So when we check the distribution of the artists among different classes, we could see that the BTS would just rock over all of the other artists, and which was an overrepresentation, which actually concluded our machine learning model to be biased. So it was a problem to solve. And we had class imbalance both in tweet dataset and lyrics dataset. And you can see we have randomly selected some tweets for you to understand the incompatibility and the loss of adaptability of this dataset on this task, because none of these texts which were randomly selected can be related to the mental disorder, which was self-claimed. So also we have limited computation resource, so we couldn't just fine-tune or train a whole new BERT model on this dataset. So in conclusion, we have tried some pre-trained feature extractors and powerful classifiers on this dataset to address the usability of this dataset and create a machine learning model to predict if a person has a mental disorder just by looking at their tweets or their music preference. And unfortunately, the achieved results were not satisfactory to put the model on deployment. If we were to use a better dataset, if we can find a better dataset, or if we can find a more computation resource to fully fine-tune a BERT model for its datasets, these can be the advancements in the future for its tasks. And as we said, the self-claimed mental disorders are actually not 100% trustable label for this dataset, as I have shown you from here. And thanks for listening to us. These are our references. Have a nice day.